Now what we need to do is we need to make sure that there are vent holes in each section. So there's the rear section, there's the forward section, and really you make some vent holes here so that as the rocket gains altitude, you don't get too much pressure building up inside, because I mean when it's at the launch pad it's at atmospheric pressure. As the altitude goes up, the outside pressure is less, so you don't want things separating. Now we will put shear pins to kind of help with some of that, but also you want to make sure things are vented right. So we'll just add, you know, a 3/16 inch hole here, 3/16 inch hole here, and actually we'll do it on this back side, and that'll be for those. Now in the actual altimeter bay, you need to vent that also, because this will be separate. So that's the other thing. I want to make sure I'm forward of, you know, make this top vent hole forward of where this is. So we want to make sure that this compartment, you know, where the parachute is, the main chute is vented, and the lower section where the drogue parachute is going to be is also vented. So not super critical. So here's where the top centering ring for the motor mount fin can assembly is. You know, right about here is the end of the altimeter electronics bay. So I'm going to add it just right here in this area right here. So try and put it in line with those, just so things look neat and orderly. Once again, use the tip of an X-Acto knife and get things started. And all that is a vent. Okay, so I want the other hole here, somewhere north of that. That kind of a place, sliding down. This blue tape won't need. Okay, both of those are vented. Now it is time to work on the shear pins. So we've got the rivets here, so I worked on those, got all the rivets fitting good. So this all stays together. So we're going to do shear pins for the nose cone up at the top, and then also for this section here. So what I'm going to do is I'm going to use 2 shear pins. Here's my little Ziploc baggie with the shear pins. And usually what I do is I'll buy these from Lock. They sell a starter kit that has like the little inky tap and then a few shear pins. Can't remember the exact. I think they're M. Let's see what this says. So here's like a drill set that I got. M3 by 4 high speed. Okay, so that's what it is. So there's a matching drill and a tap. So that's what they are. They're M3 nylon screws. And what happens here is you drill, you tap, then you screw the shear pin in there, this little threaded nylon screw, and when that holds it together until the ejection charge goes off, and boom, it separates. So when you're sizing the ejection charge, so we'll do that here after everything's kind of together and we've clear coated it and we're ready to. So we'll do some testing out in the backyard with the ejection charges. There's some calculators that'll figure out how much black powder you need based on the volume of this section, things like that. But right now we'll get the shear pins, we'll find out where we want to place them, drill it, tap it, put the shear pins in, and that'll kind of hold it in. But the whole idea is that if these actually break, you know, they shear, boom, with the ejection charge. So we've got 2 here, and then 2 up for the nose cone. So let me get things set up and we will start putting in shear pins. I think what I'm going to try and do is just line up the shear pins with these two. Well, I don't know, let's put them 180 degrees apart. So let's put them on either side here. So get some blue tape. So I want this joint to be tight. So line up our graphic there, push it together, and then lay down some tape to hold it tight. I'll do the same thing over here. Okay, that keeps things from twisting. We'll hold that joint tight. This one. And there's this one. That's 2 shear pins 180 degrees apart from each other. And we really want, you want to put this fairly close to the joint, because whenever that breaks, you want it just to break free and be able just to go, you know, be away from each other. So if you put it down here further, it's going to drag. You know, if you don't get a good shear on it, you might drag with a little piece of plastic in there. So you want to keep it fairly close. You don't need to be right on the edge, but one's going to go there, one's going to go here. Okay, so now I've got the drill that matches. What did I say they were? M3 metric. That is not a very sharp drill bit. Or I got more epoxy on that too than I thought. So all the tubes should all be hardened from the epoxy resin and CA and stuff. So and before I drill the other one, I'm going to get this one set. So just using my fingers, I'm going to run this teeny tiny tap down that hole. Slowly back it out. I usually use my fingers. It's a little tight. Takes some force, but if you put a tap handle on it, it's so small that it's, I think you just get a better feel for what it's doing if you use your fingers. It's such a small tap. Okay. Now, on these small, I've got the special little jeweler screwdriver, so let's run this in, see how it goes. Okay. And as you can see, I mean, it's holding that section together now. Well, there's tape. Well, yeah, there's tape over there. That's holding that section together, but it's a very small screw, so the black powder charge will actually break it, shear it. So go around to this side and do the same thing. Okay, let's see how this one goes in. Looks good. Well, that's that. So here are the shear pins for the nose cone. So the same idea is the the ejection charge will be set up here. The altimeter will fire the main, and then it'll shear these off. And this just keeps everything together as the rocket's accelerating up. Holds this nose cone on, but the purpose of these is to break when the ejection charge goes off. So nose cone's held in place. This is held in place. So I think now's the time to kind of maybe decide how we're going to do the altimeter bay. So I have to take it all apart again. But let's here's where the rail buttons are. So it's going to be sitting on the rail like this. So when we slide it on, I want to be able to access to get to the switch. So maybe put the switch hole here in line with that. It just things look nicer when things are kind of lined up. So yeah, I may do that. I may do the hole for the switch right there. So now it is time to work on the electronics bay. So kind of gathered up the basic parts here. So I'm using a MissileWorks RRC3 altimeter. I've got actually two of these. I'm only going to use one of them, but two of these the little screw switches. What's the name of that place? I can read it. They're like a little robotics place in Canada. They're really the best screw switches I've seen. FingerTech. Yeah, kind of a weird name. But they use an Allen wrench. So I got like a little ball driver. So they're just really simple, sturdy little switches. Screw them onto a plate. And the idea is to mount one of these screw switches so that we can access it through that hole. So it's going to be mounted directly to the inside of this the altimeter bay coupler. So then we get that mounted, then I've got this kind of assembled here too. Tighten these down, lock nuts. So that's the tray that the altimeter is going to be mounted to, and the battery. And then this will go inside here. Kind of decide which is going to be the forward end, which is going to be aft end. That will kind of decide, for the drogue charge or for the main charge. Everything's kind of, so it all fits real tight. So that's good. The wing nuts will go on there. So this is the center section. This needs to be really sturdy. So that's the shock cord for the nose cone, shock cord for the tail will be there for the fin can. So what we'll do is we'll drill some holes here. We'll mount some terminal strips so we can hook up ejection charges. I've got like little hookup wire connectors. This is my box of goodies here. So different kinds of connectors, and there's hookup wire I bought in little packages from what is the name of Doghouse Rocketry. So there's a battery box and battery connections and stuff like that. So I'll look through my little box here and pick out what we need, and we will get things hooked up. There's like even little charge wells that we can do, but usually I've found everybody kind of gets their own way of doing things. I like to make just the omnidirectional glove tip kind of ejection charges. I don't really do the little charge wells and stuff like that, and that seems to work best for me. So why change it? Why go through that? Early on when I was kind of discovering some of this stuff and doing the dual deploy, I did try some of those little charge wells. They're just, to me, they just seem finicky to have to get the black powder inside of them, put the E-match in there, cover it up somehow so it doesn't all fall out. And to me, it just seems more secure to have it all wrapped up in a little glove tip, taped up, and then I just kind of set it here, run the wires, hook it up to the terminal strip, and then it's hooked up to the altimeter, and that just seems to work for me. So you know, do whatever you want to do. I like to do it that way. So when we come back, we'll start laying out things on this tray. There's plenty of real estate on these, especially for what I'm doing. You know, to lay out the altimeter and put a battery here. I usually try and put the battery on the rearward, the aft end of it, so that, you know, as it accelerates, it's holding up against this, and so to kind of keep it from jostling around, then I'll usually glue or put a screw or something to kind of help hold that battery in place. I do have some of those battery boxes. We may use that too, so we'll just kind of see how things go, and I'll update you when we get it going. So I'm going pretty simple with the battery mount. So what I'll do is just mount the battery on the bottom side of the tray. I've already drilled some holes for some zip ties. So when I get the connector here for the battery and get it all wired in, I will run another strap through those holes to kind of secure it in there, another zip tie. So the altimeter I'm just going to mount right here in the center. The battery connector is on this end, so the battery wires will come up and mount right onto it. There's the switch, so this switch will come up and then go to the switch. I'll do a quick disconnect, or a little connector kind of a thing on that, using like these, so that as I pull it out, I can quickly disconnect that, because the switch itself will be mounted to the inside wall of this, where that hole is. So what I do here on these is I've got a few screws. I've just sliced off some pieces of rubber hose. That's kind of my little insulator spacer. So the screw will go through the hole in the altimeter, use that, and then that'll mount into the board. That provides a little space between the altimeter and this board, so nothing's rubbing. And if it needs, you know, I think on the bottom side is actually where it senses, well, maybe not. Yeah, I think this chip right here is the one that senses the pressure. So it needs a little space. You don't want it squished down against anything. So that should space it up a little bit, and give it a little shock mount to, a little shock resistance to, with the rubber hose. So anyhow, I'm going to get that going. I've already marked, and I'll drill these holes for these screws so that it doesn't split anything, and then I'll get the altimeter mounted. Here's the update. We've got the altimeter mounted onto the tray. Good thing I spaced it up, because it turns out where I place these batteries for the straps, I need some space anyway to run the zip tie underneath there. So live and learn, but looks like that's going to work. So I've got one half of this quick disconnect, or the little harness here, hooked up to the switch terminal, and then this is the battery. So the battery's hooked up right now. So we should be able to, just to test the altimeter, plug this in and short the wires on the end, and that should basically act like a closed switch. Let's see if the altimeter powers up. So that's good. And let it go through its diagnostics check. Now I think once it's done, it'll give 3 quick bursts if it doesn't have any charges hooked up. That must be the tone for no charges hooked up. Okay. So good deal. Disconnect that. So now the end of this will need to be wired into our little screw switch. So what I'm going to do is get to soldering over here. Hopefully the soldering iron is nice and hot now. We will solder these leads onto each of these terminals, and then when you screw that switch in, that should basically do the same thing. So when I'm done with that, we'll come back. There we go. See how that kind of flowed there towards the end? Hopefully you can see it. A little extra rosin on the back side of that one, so I will get a Q-tip. Let me try and flow this one a little bit better. Not the most beautiful thing, but those are good solder joints. So let's plug it in. Let's see what we did. Got my little ball driver Allen wrench here. Turn it out. And it works. Took a little sanding, but that's a pretty good fit. So now I want to cut out basically a pad for this guy to mount on, or that can be next to that hole. So just like whack it off here. Just cut to fit, paint to match. So on the screw switch, there's nothing very high tech here. What I've done is I just got that piece of plywood, mounted the switch to it, got a couple of thicker pieces of balsa wood just kind of help support it and give it more gluing area. But the idea is a little bit of surgery here, but you look through the hole, line up that screw switch, and glue it in there. So I'll probably just use good old tight bond wood glue to do this. But on the inside, you know, it'll be mounted like that, if you can see it. And then you'll be able to go right in here, and there's the screw switch, and turn it on and off. It also kind of acts as a little bit of a sensing port too for the altimeter. So that's that, and I'll get that glued in. And then we'll carry on.